Look up at night on a clear evening and you'll see the moon, hanging like a pearl in the inky sky. It's a constant presence, a celestial beacon that has captivated humanity for millennia. It's Earth's closest neighbor in the vast expanse of space, and our only natural satellite, a loyal companion in our cosmic journey. The moon itself doesn't make its own light. It's not a star. Instead, it reflects sunlight, acting like a giant mirror in the sky, scattering the sun's rays back towards us and illuminating our nights. Up close, the moon is a rocky, dusty world, quite different from our vibrant Earth. Its surface is sculpted with mountains that reach for the heavens, deep valleys carved by ancient impacts, and countless craters, each telling a story of cosmic collisions. It's about 384,400 kilometers away from us, a vast distance by human standards, but relatively close by cosmic standards. Its surface is covered in a layer of fine grey dust called regolith, a substance unlike anything we find on Earth. This regolith was created by billions of years of meteorite impacts, a constant bombardment that has shaped the moon's landscape. The dark patches we see on the moon, called Maria, which is Latin for seas, are actually ancient volcanic plains, vast expanses of solidified lava that flowed billions of years ago. In contrast, the lighter highlands are older, heavily cratered regions, a testament to the moon's long and violent history. Scientists believe the moon formed from a cataclysmic event. A Mars-sized object collided with early Earth in what's known as the giant impact hypothesis. The debris from this collision swirled in space, eventually clumped together under the force of gravity, and slowly coalesced to become our lunar companion. In a way, the moon is a piece of our own planet, a tangible link to Earth's distant past, and so the moon continues its eternal dance, forever circling above, a silent witness to the passage of time. The moon orbits Earth in a steady, predictable path, a celestial dance that has captivated humanity for millennia. This journey takes about 27.3 days to complete a single trip around our planet. This period is known as the sidereal month, marking the time it takes for the moon to return to the same position relative to the stars. Intriguingly, the moon spins on its axis at almost the exact same rate that it orbits Earth. This synchronous rotation means we always see the same side, the near side, with its familiar patterns of craters and Maria. However, the moon's orbit isn't a perfect circle. It's slightly oval or elliptical. This means that sometimes the moon is closer to Earth, a point called perigee, and sometimes it's farther away, known as apogee. When a full moon coincides with perigee, we experience a supermoon, appearing larger and brighter in the night sky. As Earth spins on its axis and orbits the sun in its own grand journey, the moon's movement becomes an integral part of a complex cosmic dance, a delicate interplay of forces. This dance is all meticulously balanced by the universal force of gravity. This gravitational pull is what keeps the moon perpetually locked in its orbit around Earth, making it a constant and comforting presence in our night sky, a beacon in the darkness. And then there's the far side of the moon, often romantically called the dark side, which is really just the hemisphere we never get to see from Earth. It's not actually always shrouded in darkness. The moon's continuous journey around Earth is a beautiful and awe-inspiring example of celestial harmony and precision. Together, Earth and its moon embark on a shared voyage around the sun, true partners in the vast expanse of space, forever bound by gravity's embrace. Take a moment to observe the moon over the course of a month. You'll see it change shape in a mesmerizing dance across the night sky. These are its phases, each with its own unique appearance and name. The phases we observe depend entirely on how much of the sunlit side of the moon is facing Earth at any given time. It's all about perspective. This sunlit portion changes continuously as the moon gracefully orbits our planet. The cycle begins with the new moon, a phase of hidden beauty. During the new moon, the sunlit side faces completely away from us, rendering the moon virtually invisible against the backdrop of the night sky. As it continues its journey, we begin to see a sliver of light, the waxing crescent, a delicate curve in the darkness. Then comes the first quarter, where exactly half of the moon appears illuminated, a perfect semicircle in the sky. Following this is the waxing gibbous phase, where more than half of the moon is lit, growing larger each night. Approximately 2 weeks into the cycle, the full moon graces our skies. At this point, Earth finds itself positioned directly between the sun and moon, creating a spectacular celestial alignment. As a result, the entire sunlit side of the moon is visible to us, shining brightly in the night. After the full moon, the illuminated portion begins to shrink, marking the start of the waning phases. We first enter the waning gibbous phase, gradually losing light. Next is the third quarter, also known as the last quarter, where half of the moon is again illuminated, but on the opposite side from the first quarter. This is followed by the waning crescent, a shrinking sliver of light. Finally, the cycle completes, returning us to the new moon, ready to begin anew. This entire cycle from new moon to new moon takes approximately 29.5 days to complete. This is slightly longer than the moon's actual orbital period, because Earth is also moving around the sun during this time, affecting our perspective. Throughout history, people across the globe have meticulously observed and tracked the moon's phases. These observations have been instrumental in developing timekeeping systems and creating calendars that have guided human activities for thousands of years. The moon's ever-changing face, a constant presence in our night sky, serves as a timeless cosmic clock, marking the passage of time and connecting us to the rhythms of the universe. The moon's gravity tugs on Earth, creating ocean tides. Water bulges out on the side closest to the moon, causing high tide, and another bulge forms on the far side. As Earth spins, different places pass through these bulges, so most coasts get 2 high and 2 low tides each day. The sun also affects tides, but the moon's pull is stronger. When the sun, Earth and moon line up during new or full moon, we get extra high spring tides. The moon's invisible pull shapes our oceans and coastlines every day. Without the moon, Earth's tides, and life along the shore, would be very different. The moon's gravity is a silent force that connects us to the cosmos. For centuries, people dreamed of visiting the moon. In 1969, that dream came true when Neil Armstrong and Buzz Aldrin walked on its surface during NASA's Apollo 11 mission. 6 Apollo missions landed 12 astronauts on the moon, collecting rocks and running experiments that revealed its secrets. These missions confirmed the moon's origins and taught us about its history. Today, robots and orbiters continue the exploration, and new missions are planned to build a permanent base. The moon is our gateway to the solar system, a place of discovery and inspiration. As we look up, the moon reminds us to keep exploring. Our lunar neighbor is just the beginning of our journey into space.